Okay, so this video do a quick rundown of what a stem plot looks like. So we'll kind of look at how do you create a stem plot and what kind of information do we get once we got these stem plots. So another way you might have seen this before is a stem and leaf plot. So the big ideas here, what you kind of want to do is it helps us sort the data, and that'll help you identify the minimum and maximum values. So we can kind of see, well, what kind of stems do we need, and then what kind of leaves are we going to use in terms of, do we break this up by tens and ones? Maybe there's money involved, and we'll kind of look at that again in a second. And the big thing, if one of our rows becomes so big that it's going to be kind of hard to tell what's going on, one of the things we can do is kind of split the leaves in half, and I'll show you how to do that right here in just a second. And we want to make sure, in the end, you definitely want to make sure that we get this legend done, because that's where we're going to show our units, and it's going to help somebody be able to read our stem plot. So here's some data about student heights. So let's create a stem plot or a stem and leaf plot to show this. So the first thing we want to do is we can create a title, heights. And because everything's in the 60s and 70s, what I might do is I'm going to split my stem right away. Here the data is already sorted for us, luckily. And so what we'll do is, you can see this, the 10s, the 60s and the 70s are to the left side of that line. And then we'll just go through. So there's somebody that's 61 inches. We have 64, 64. Now, I split the stems, so what this is going to allow me to do is kind of get a better look at the distribution. Instead of just having a big row for 60s and a big row for 70s, I'm going to split the 60s in half. So everything from 0 to 4 will go in the first stem. Now that I've done all those numbers, we're on to the second half of the 60s. So I've got a 67, I've got 3 68s. Looks like there's 4 69s. And then I've exhausted all my 60s. Now move on to the 70s. So we have a 71, a 72, a 72, a 74, and then 176, which will go there. So when I look at this, what this tells me, you can see that there are 2 students that are 64 inches tall. The key here is what's going to kind of give us somebody our units. It doesn't matter what you pick, just pick one of them. So I'll do 6, 7, and just tell your readers that this is equal to 67 inches. So there's how we're going to get our units, right? We got a title, we've got our units kind of identified what's going on. Now, if we were to describe the distribution, go through our socks. This is a little bit trickier because our data is going vertically. It does look like there's maybe a slight skew to this. So a way that we can get around this, instead of trying to figure out, is it skewed to the right, skewed to the left, which you can see below, right? We have a unimodal distribution, and there's it's slightly skewed toward the larger heights, right? If we go and we put our curve in here, right, it kind of tails off. Another way that you might look at this, if you could imagine rotating this, counterclockwise, then you could maybe say it's skewed to the right. Some people might look at that and say it's pretty symmetric. So you could maybe even slightly skewed right here. You wouldn't be wrong if you said it's relatively symmetric. I see the slight skew, and this allows me to also say we're slightly skewed toward the larger heights. As is, none of the observations really jump out at me in terms of outliers. So instead of just claiming there are definitely no outliers, I'll say there do not appear to be any outliers, because as the unit progresses, we'll talk about how to actually algebraically determine outliers. Here, the median of the data is 69, and the way I did that, you kind of go old school. You can kind of, if you'll excuse me here, I kind of work my way through the list. Boom, boom, right? You kind of pick your way through, getting rid of one at a time. There's the median at 9, and sure enough, that's 69. So there's where I got the median of 69 inches. So there's my center. And then the range is 15 inches, 76 minus 61. So I did spread, I did center, I did outliers, and I discussed the shape. So there's my socks. So like we said, with student heights, because everything was in the 60s and 70s, you could probably split it. Here in this particular example, maybe we don't want to split the stems because there's a 59, so all of a sudden we could do 5, 6, and 7, and then we could write our stuff in there. Price for a gallon of gas in recent weeks. Well, here's one where all of a sudden maybe the stems could actually be the dollars, and then the leaves could be the scents, right? And the legend or the key will tell people that. This might be a good one where we maybe want to kind of split it up and do a split stem where the first dollar is anything below $1.50, and then the second one is anything from $1.51 up to $1.99. And then we split from about $2 to $2.50, and then from $2.50 on up with this last one. And then maybe a recent test on a recent score, on a apes test. So here we go all the way from the 60s up to 100. So maybe our stems here, 6, 7, 8, 9, and 10. And then we could go from there, right? So you have a 69, you have a 75, you got a 99, an 83, a 91, an 88, 95, another 91. I already put the 69 in there, 64, and a 102. This, just again, to kind of point out to you, you actually don't have to put your leaves in order because you can still get a pretty good sense for, well, what's the shape of this? You can see this one would be slightly skewed toward the lower numbers. We get a sense for where the center of the data is. Looks like it's somewhere maybe in the high 80s to low 90s is perhaps the center there. You can't do our median trick where we crossed them off like we did on that one. We can't do it here since these aren't in order, but you still get a pretty good sense. You can get the range pretty easily from this one. So one thing to realize, as you do these, notice we didn't put any kind of commas in between our values in either one of these stem plots. The legend will tell people how to read it, whether you need 1 digit from the leaves, 2 digits from the leaves, or whatnot. So don't put commas, periods, dashes, anything like that in between. Sometimes you want to compare two sets of data that are very, very similar. So we could use back-to-back stem and leaf plots. And here, basically, the stems are just going to go to the middle, and then the leaves will go to either side. So here's some data, guys versus girls heights in a class. So what we can do, again, I'll probably split this just because we've got 60s and 70s. So we'll do girls. You'll have to excuse me, I'm having to boys on this side. And then start picking through. So 61, 64, 64, we got a 67, 68, a 9, a 9, a 9, and a 71. For the guys, we go 67, 67, 68, 70, 70, 71, 73, 73, 74, 75. So what we could do over here, just to make sure people can read it well, since the girls, you kind of start in the middle and work left, we'll do a legend for the girls. All right, maybe we'll kind of highlight this. I apologize, it's a little bit messy there, and then since we're starting in the middle and going to the right for the boys, we'll make sure that that's aware. People are aware of that too, right? Now, if we were asked to describe these two distributions or compare them, the big thing we want to make sure we do is use comparison words, bigger, smaller, larger. So as you look at this, it actually looks like both of them are pretty symmetric. Not exactly symmetric, but relatively symmetric. And then as we talk about centers with this one, we might say, well, the center of the girls is maybe 69, which is lower, right? The center is probably here for the girls, which is lower, there's your comparison word, than the center of the boys, which looks like it's going to be in the low 70s, right? The range for the boys looks like it's 8 inches versus the girls, which is 10 inches. So the girls have a larger range in heights than the boys for this particular class. So if you're going to compare two data sets, just make sure that we're using comparisons.